Well, hello, everyone. My name is Doug Stevenson. I'm a developer advocate with the Firebase team. This is my first time in the Ukraine, so thanks for having me. It's been really good so far. Who here is already using Firebase in a mobile app? Okay, like 3 people. All right, so you're going to learn something new today. Firebase is Google's mobile application development platform. As you can see, there are a lot of different products within Firebase. So there's databases, push messaging, crash reporting, testing tools, and some more things behind me here. These all work together to help you build, improve, and grow your mobile application. One of these components I'm going to talk about in particular today, Cloud Functions, is special to me because I get to use it all the time for work. It's a lot of fun. Cloud Functions is serverless programming. So if you don't know what that means, I'll go over what serverless means to most people today. Right now it supports JavaScript and also Python, but for Firebase developers, JavaScript is the first language you should know, and it runs in a managed Node.js environment. Now, the name of the product that I'm using is called Cloud Functions for Firebase. Let's unpack that a little bit. Cloud Functions is actually the name of a Google Cloud product. So Cloud Functions is a Google Cloud product, but Firebase adds tools and APIs on top of that. So there's a command line interface, there's SDKs, there's extra things to help make it easier for Cloud Functions to work with your Firebase product. So I'm going to take a Firebase view of Cloud Functions. So I mentioned before, Cloud Functions is serverless. Well, what does that actually mean? For most people, it's not a surprise. Serverless actually has servers. You can't escape servers. Your backend code has to run somewhere, so there are servers on it. So given that there are servers, what do we need to know about a serverless environment? Well, the first thing is there's no maintenance. So if you're like me and you develop a lot of mobile apps, you want to spend time on your app and not on your infrastructure. So you can write and deploy code to a backend that has no maintenance. So no logins, no SSH keys, no upgrades, no patches, no nothing. You just write and deploy code, and that's the end of it. Serverless backends scale up and down. So when you deploy your code, if no one's running it, you pay nothing. There are no server instances. Now, when people start putting load on it, the system will allocate instances as needed to scale up to demand and back down. And I'll illustrate that a little bit later. And you only pay for what you use. Because you don't stand up and manage your own server, there's no 24/7 server cost. So if you run a function, you pay for one function, and that's it. There's nothing more complicated to it. But it's also event-driven. So the code you write responds to events in your Google Cloud or your Firebase product. So it's reacting to things. It's not scripting, it's just reacting to things. So I'll illustrate that a little bit more. With Firebase, some of the products will emit events. So that's what we call event providers. And they emit events. And these get captured by Cloud Functions. And what Cloud Functions will do is figure out if this event is interesting to a function, and it will trigger your function, deliver it the event, and it can do what you want. So everything works like this except for HTTP functions. The event is the HTTP request. And I'll show you a little bit about that later. Cloud Functions scales up and down with load. So as you have users hitting your function, Cloud Functions will instantiate a server instance for you automatically. You don't see it, but you know about it because your functions run. And as you get more and more users, more and more server instances are allocated. This keeps going as long as you need it to scale up. And I believe with Cloud Functions, you get up to 1,000 server instances per function. So if you write one function, you can have it running concurrently in 1,000 different server instances. And as your users leave the app, the system will automatically scale down to 0. And you pay nothing, again, if you're not running any functions. Okay, so this is a list of event providers. This is actually incomplete. There's a new one, but I'll go over these real fast. You can write HTTP endpoints, meaning you can create a web API that's serviced by your JavaScript code. If you're using Google Cloud Services, you can have a pub/sub subscriber that effectively runs some code in response to messages going to a pub/sub topic. In cloud storage, when a file is uploaded or changed in your cloud storage bucket, you can write a function that responds to that. With Cloud Firestore and Realtime Database, these are NoSQL cloud-hosted databases. And when some data in your database changes, you can write a trigger in response to that. That's one of our most common use cases. With Firebase Crashlytics, if there's a crash in your app, you can know about that. You can run some function to maybe call your pager or maybe create an issue in Jira. With Firebase Authentication, when someone new logs into your app, you can know about that and write some code to bootstrap their account. And with Google Analytics for Firebase, what you can do is trigger unconversion events. So if there's a very important event or something that happens in your app that meant that your user did something important, like buy something, you can write some code to respond to that. So these are event providers. I will talk about HTTP, cloud storage, Firestore, and real-time database. I'll give you some live demos of those later. So why should you use Cloud Functions? If you're already familiar with running and managing your own backend, that's fine. But I think that Cloud Functions is helpful from a mobile application perspective because you don't have to repeat yourself. If you have an Android app and an iOS app and a web app and they're all supposed to do the same thing, why duplicate that logic among all those platforms? Instead, use Cloud Functions. Put the logic in one place. Don't repeat yourself. With Cloud Functions, your app can be fast and reliable. So I don't know if you don't do a lot of mobile application development, you probably aren't familiar with the fact that mobile applications come online and offline very often. In fact, as I've been going around Kyiv lately, I have okay service, but sometimes service just drops out. Then it comes back in and it drops out again. And so you really can't depend on mobile devices being very well connected or even being very fast. So what you can do is offload work to Cloud Functions to run in the background while the app may not even be online. The last thing is, and maybe this is the most important one, is we should never trust a user's device. The moment you ship code and it gets in your user's hand and they run it, you can expect that someone will hack it. They can decompile your APK or your API, what do they call it in iOS, IPA, or they can just look at the code from your website and they can reverse engineer it, decompile it, and make it do whatever they want. So you shouldn't trust code that runs on a user's device. So I think all code that should be secure should be on a backend, and Cloud Functions is the best place for that, or a really good place for that, I think. So I've talked a lot about Cloud Functions. Some of you maybe already know this. I think it's helpful to get to know Cloud Functions by actually working with it. So let's see. I will switch. So right here I have a terminal. You can see that okay. So what I'm going to do here is create a project or create a directory, CD in there. Now, I already have Node installed, so this is a requirement. Of course, NPM is installed. And there's a Firebase CLI as well that you need to have installed. So all these run in Node. Once you have these tools and a code editor, you can start writing Cloud Functions. So I'm going to initialize this project. So I've already created a project in the Firebase console. I'm just going to go ahead and work against it. So I'm going to point my project at that project I already created. Oop. I have to do it right. You know, every time I run through this demo, I make some mistake, and it makes me look really bad. So please bear with me. I will make a mistake, and the demo will look bad, and then I'll correct it, and then it'll look good again. You can choose, using the Firebase CLI, what you want. I don't know if you can see me switching down there. I like TypeScript. Is anyone here using TypeScript? Okay. Three or four, and I'm sure, very enthusiastic people. TypeScript is basically JavaScript that isn't terrible. I've done a lot of JavaScript, and I learned to hate it. TypeScript makes a lot of that a lot better. So I'm going to write my functions in TypeScript. And I am not going to install dependencies right now. What I'm going to do is load up VS Code. And I love VS Code for editing TypeScript, by the way. So what this created for you was a Node project, and every Node project has a package.json. So if you know Node, this should look very familiar. The Firebase CLI will bootstrap it for you. So it's pointing out that your entry point, this is where all your functions must be defined. It's also created some dependencies. Now, I know that these dependencies are out of date, so what I'm going to do is I'm going to update them manually. So I'll do npm install Firebase admin, Firebase func. I have to type everything correctly. Let's see, tslint and TypeScript. Now, while this isn't installing, I'll go over a little bit more. I use tslint for just about everything. It comes up with a lot of great warnings. So the tslint JSON configuration that's created for you is opinionated. It's the configuration that the Firebase team thinks you should use. There's a ts config. You can see here that TypeScript is compiling down to ECMAScript 6, and it's using CommonJS as a module format. It's going to pull in everything from source and write it all out to lib. So the source directory, they've given us a index.ts with the sample function, and in fact, we can just actually go ahead and uncomment it and get rid of all the, and I also hate semicolons. This is my personal thing. I hate semicolons. All right, so it looks like all of the packages are installed now. So what this function is doing is it's declaring a function called hello world that's going to be exported from this module. It's using the functions SDK to declare an HTTP trigger. And when an HTTP request comes in, it's going to trigger this code, which gives me an express request and response object. It's not real Express, but if you know the Express API, you already know how to deal with the request and the response. And what it's doing is just sending a simple text string to the client. So I don't know, let's just deploy this. Firebase deploy. That's all we have to do is Firebase deploy. Now what this is going to do is it's going to compile the TypeScript into JavaScript, and it's going to put it in this lib directory. And it's slowly doing this. You know, I should have asked for a wired connection before I did this. I think that would be faster, but that's okay. This is much faster in the speakers lounge. Anyway, we've compiled the TypeScript to JavaScript. It looks very similar, but you can see that TypeScript is sort of smoothing over some of the problem parts of JavaScript. This is taking way longer than I expected. Is there any chance I can get a wired connection? Anyone? Can I get an internet connect, like a wired internet connection? Only Wi-Fi? Okay. Because it's making my demo take very long time. This, I'm on the speakers, yeah. So I don't have much of a demo if I can't deploy code, unfortunately. This is taking a very long time. What I would do at this point, yeah, so that's a good point. What I can do, I can do Firebase serve. What that will do is it will set up a local emulator. So this is a good point. I can run Firebase serve. Unfortunately, Firebase serve also needs an internet connection. So if it's doing anything at all, okay. So what Firebase serve did is it detected I have a function called hello world, and it gave me a URL to that. So what I can do is copy that, and then oh, that's really small. That doesn't work well at all. So I can use curl and run it. So I have hello from Firebase. So that's still not much of a demo. It just says hello from Firebase. I need to do something interesting with it. Maybe it's stuck. I'll try it again. Oh, hey. Oh, it was just stalled. Okay. Now this deploy will do the same thing that the emulator did. It will give me a URL. I'm anxiously awaiting this URL. I appreciate your patience. This is ending up being a really terrible demo. And I ran through it this morning, too. I wonder if I should use my phone as a hotspot. That might actually be faster. Do you think Devoxx is faster than the speakers? Okay, I'll give it a try. That would be terrible if they gave the speakers the worst connection. This is very, I'm going to have angry words later on here. Okay. Deploy. If I don't run at least one function, because I have like 4 other functions to run, if they're all going to take this, yes. Oh wait, no, you don't have to wait anymore because I have a URL. I will definitely answer some questions at the end. Okay. Oh, that's the console. Oh, it didn't give me oh, that's because I probably already had it deployed. You know what, we'll just go into history and find it. It's not there. That's okay. I'm not even going to bother running this one because you saw it run in the emulator. But what I will do is I'll create a new function. So HTTP functions that do nothing interesting but just send something, that's not a big deal. What I want to do is something more interesting. So let's say in the Firebase console, this is what the Firebase console looks like for my project. One of the databases in there is called Firestore. Now, Firestore is a cloud-hosted NoSQL database. It makes you organize everything into collections. So a collection is sort of a top-level unit. It's a container for document. And so what I'm going to do is create a messages collection, and I'll pretend like I have a chat room in here, some sort of like a conversations thing. So inside messages, I'm going to create a document with a field called text, and I'll say, this is my first time in Ukraine. And I'll spell it right. Okay. So what that does is it'll create a document with an ID, and that you can see the fields of the document are over here. So this is the general structure. I can keep adding documents like this, but what I want to do is when I add a new document to this collection, I want to make some changes to the message text. So one of the things I noticed when I booked my travel here is sometimes Kyiv is spelled K-I-E-V in English, and sometimes it's spelled K-Y-I-V. And I didn't know why that was. I was kind of confused about it. So I looked up and tried to figure out what the difference is. And it looks like K-Y-I-V is the preferred, like the new English spelling. So what I want to do in this chat room is make sure that all the messages coming in use the new spelling over the old spelling. So what I can do here is create a new function, and I'll call it fix up messages. I'm sorry? Oh, that's a good point. Yeah, I should. I didn't realize I was already selected there. Thank you. Okay, so what I can do here is copy some of this that came out of index.ts. And paste it in here. So I'm going to use the Firebase Functions SDK, and I'm going to export a new function called fixupMessages. And I'm going to use the Firebase SDK to declare a Firestore trigger. That Firestore trigger is going to trigger when a document changes. And the document I'm looking for is a pattern. I'm going to say anything under the messages collection. And so this will trigger anytime there's a new document added. So on create will give me a lambda that I can execute. So when a new document is created, what it will pass me is a snapshot of the document that was created and some context, which I won't use. That's okay. What I can do here is I can look at the snapshot. There's an error here. I'm missing an arrow, yeah. So I can look at the data. So when I call the data method on the snapshot, that's going to give me a view of the data. It's going to be just a regular old JavaScript object with the fields of the document mapped to properties on the JavaScript object. Then what I can do is reach into it and say that text field that I created, I want to use that. So I'm going to use text. And I know it's a string, so I'm going to go ahead and cast it as a string. Thank you, TypeScript. Now what I want to do here is modify this string and write it back into the document where it came from. So I can take that snapshot. The reference to that is the document. It's a reference to the document that was created. And I can call update on that. And update lets me pass an object into it. And so what I'm going to do is take the text and replace Kyiv with Kyiv. And so what this does, update returns a promise. So if you're a JavaScript developer, you know that you need to deal with promises. The way Cloud Functions works is you need to return a promise that resolves when all the work is done. Now I like async await, so I'm going to make this an async function, and I'm just going to await. And that's all there is to it. So, one other thing I want to do is I want to refactor this a bit. I want to create a new hello world, copy the hello world out of here into that. Actually, I need this as well. And what I want to do in this one is export from hello. I'm going to export this function, and I'm going to do the same for fix up messages. All right. So my index.ts is now just looking in 2 other files for the function. So with all this in place, and I need to save that, I can run Firebase deploy again. And you can see this time it's going to pick up that there are 2 functions to deploy. So it's doing both fix-up messages and hello world. Now this is kind of inefficient. All I really wanted to do was deploy fix-up messages. I didn't want to do hello world too. The Firebase CLI has a syntax for that. So the next deploy I do, I'm only going to deploy the function that I want to change. It'll make things a little bit faster. All right. Yes, this the speaker's Wi-Fi is just terrible. This one's so much better. Okay, let's go into Firestore here. So let's make this bigger. All right. So let's add a new document, give it a new ID. It's a text string, and say, yeah, okay, that's good. Beautiful. All right. Let's see what happens here. So there's a cold start time for functions. Give it a moment to warm up. There's also some delay between when you deploy and when a function. Okay, did you see it change there? If you blinked, you might have missed it. We'll do another one, another auto ID with text. I'm enjoying this. It is kind of cold, but I am enjoying it. And it already it changed it before it could even show in the console. So now we have 3 messages in here. We have a function that's automatically replacing text. It's kind of a silly little function, but it illustrates some of the things you can do. Now this hello world function, this is not very useful to me. Instead, what I want to do, I want to change this so that I can pull out all the messages in Firestore. So Firestore, I have these three messages. I want to create an API on top of that. So what I'll do is I'll make this async. I'll also import the Firebase admin SDK. So Firebase admin basically gives you programmatic access to Firebase products. And with that, I can, what can I do? I can reach into Firestore. Yes, I did. Thank you. See, there's always a mistake, and I always do something silly. So I'm going to reach into Firestore. I'm going to look in the collection called messages. I'm just going to call get on that. Get returns a promise that resolves with a query snapshot that has all of the documents in that collection. So I'll just await it. Q snapshot. So that query snapshot is a query snapshot type object, so I can say QSnap. Docs property gives me a list of all the docs, and I can convert them. So what it's giving me is actually a document snapshot. And if I call data on that document snapshot, that'll give me a JavaScript object that I can use. So now what I've done is take all these document snapshots and turn them into document data objects. And I'll just say const docs equals that. And now I can say response.send docs. That's all there is to it. The Express API here is smart enough to turn this docs array into a JSON object. So it will serialize it as JSON on the way out. So what I can do is go ahead and deploy this. Actually, there's one other thing I need to do. And no, I should just close this. It's not useful. All right. There's one other thing I need to do. Import star as admin from. And I need to initialize the admin SDK here. So this will initialize it for all the functions. All right. And I will go ahead and deploy only functions hello world. So this will deploy the hello world. Now I need to know what the URL is for that. It didn't give me that before, so I need to go into the functions dashboard and copy that. So this is the URL it assigned to me for this. Don't need this anymore. Don't need that. Come on, go faster. So just to remind you, there's 3 documents in here. Okay, the deploy is done. Now this is where the demo gets a little bit dicey because it can take some time for HTTP functions to update, to override the old one. So I can access this, but it's very possible I might get the old function. So it's still returning the old one. I'm just going to keep pinging it until it finally updates. It can take anywhere from 10 to 20 seconds to do that. Or it might be returning cached results. Come on. Update. Oh, it's thinking about it. This is looking good. Okay. Let's make this a little bit nicer to read. Okay, so now what we did with just a few lines of code is we made a web API to fetches down all of our documents in Firestore, which it only took a few lines of code. I mean, there's really not much to it, but it's really powerful, as you can see. You can quickly put together something that's very useful. So that's what Hello World does now. We should rename it, but I won't bother with it now. Now, what I want to do now, I have some more demos staged. They're not to be live coded because they take too much. They're kind of lengthy and they're more complicated. So I'm just going to copy some in here. So which one do I want to do? How about copy scores to sheet? So what this one does, this is an interesting one because what it does is it will take data from my Firebase Realtime Database and copy it instantly into a Google Sheet. Now, is that helpful? Well, I don't know. It might be. It's kind of fun to watch. But there's a few things you should know. To run this, you need to enable the Google Sheets API, and I've already done that in this project. And I also need to install some modules. So I'm going to go ahead and run Lodash, which is everyone's favorite JavaScript API, and Google APIs, which gives me the Google Sheets API. Let me close that and open it again. That happened last time. This is wrong. There's actually Google APIs in there. So let's see what this does. It's going to pull out the Sheets API. It's going to need a spreadsheet ID for the spreadsheet to update, and we need a service account. So the first thing is to go get this spreadsheet ID. So I already have this thing loaded up. I should delete that. Okay, tiny little thing. The ID for this sheet is embedded in the URL, if you can see that. So I'm going to copy that out, paste it in here. The other thing I need is a service account. So service account lets me emulate my function as some other user, some other privileged user. So what I need to do is get a service account for this project. What I'm going to do is go back into the Firebase console, look at users and permissions. Look at service accounts. Now, if I'm using the Firebase admin SDK, it's already created a service account for me. This is the default service account for Google projects. So I can create a new private key, and that key is what I need. So it's going to create this JSON file. Now, what I need to do is move that into my project. So I'm going to take that project. I'm going to move it into service account.json. And I believe this is the right directory. So now I have this service account file. This is all private stuff. You don't want to share this with anyone except for people who you want to have admin access to your code. But the important thing here is there's this email address. This email address uniquely identifies this user in the realm of Google products. Now, the one thing I need to do to make this sheet work is I need to share access to that email address. And I have to make sure it has edit access. When I do that, now this service account can write into this spreadsheet. Let's see, so I don't need to look at this anymore. So I have my spreadsheet ID, I have my service account. What this code is doing is it's authenticating using this service account, and it's saying, I want to be able to write spreadsheets. That's what this is saying. What it's going to do is, let's see, let's make this a little bit smaller. Can you still read it okay? So I'm defining a new function called copy scores to sheet. This is using the functions API to reach into my real-time database. Anytime anything changes under scores, anything that's written, I'm going to get a change object that describes what changed in that write. So what I can do is grab the data at that location in the database. I'm going to do some JavaScript stuff to just sort it. So there's going to be name-value pairs. So a name and a score. It's going to sort them by score. Then what I'm going to do is use the Google Sheets API, authenticate with the service account, reach into the spreadsheet, update a range of scores. So A7 to B, you know how sheets work. A2 is the first column, and B7 is the last column. And I'm going to write the scores directly in there. So let's see how this works. I'm going to save it. I'm going to re-export it. And I'm going to deploy it. And if all goes well, what I can do then is make some changes in my real-time database and see that immediately reflected in the sheet. Now this is kind of interesting, I think, because a lot of times I have an instinct to build a web app or build a mobile app for something. I don't think that's always necessary. I think sometimes Google Sheets can be your app. If all you need is a dashboard, if all you need is a display of current data, is a spreadsheet good enough for that? Well, if it is, consider using Cloud Functions to reflect data that's changing in your database directly into the sheet. So now anyone who's looking at that sheet has a live view of the data that's in there, which I think is kind of interesting because my app is just the function. The function is the app. I haven't written any client-side code. The client is Sheets, and everyone has Sheets because that's just a website. So I avoid having to do a lot of work if all I want to do is show something in a spreadsheet. So let's shrink this down so we can see them side by side. Let's see what I'm going to do here. Okay. Now I'm going to go into real-time database. No, that's Firestore. I want real-time database. What I'm going to do is go ahead and create that location called scores. I'm going to give myself 1 point. I'm going to give Kyiv 10 points. And who's going to win this game? Devoxx. It's going to come in with 111 points. So we can add this data to the database, and you can see it automatically appeared. Now this is kind of cool, right? And it's live, right? So if any change I make is instantly transported into this database. Now think about the possibilities here. I haven't done this, but I know some people make very fancy graphs in Google Sheets. Imagine if the data that's feeding your chart is live updated through a function. So now you can have very live charts. So if you do anything at all with metrics and you store that data in a real-time database or Firestore, you can have that immediately reflected in a spreadsheet that anyone can use. So I think that's pretty handy. All right. Let's close that down. All right. How about another demo? So there's another interest. Let me talk about this, what it's going to do before showing you the code. So there's another thing I want to do. I wanted to build something, a little web app, that let me drag an image into the web app, and then it would automatically tell me, it would use the Google Vision API to tell me what is in that image. So imagine uploading an image to a website, writing the metadata about the image to real-time database, uploading the image itself to cloud storage. Now what we can do here with Cloud Functions is write a trigger that triggers some function that goes off and calls the Cloud Vision API for me. Now what Cloud Vision API can do is read that image directly from cloud storage and get a list of labels. It's called labels, but it's properties or things that are found in the image. And then when Cloud Functions is done with that, it can write those labels back to Realtime Database and reflect that back into the web UI. So let's see how that actually works. So let's go over here. I'm going to copy a new, let's see, from stage. I'm going to do on image upload and copy that into source. So now I have a new function here. So this requires billing, just so you know. This requires the Cloud Vision API to be enabled, which I already did. And it requires the Google Cloud Vision node module, which I'll install right now. So while that's installing, what it does is we create a Google Cloud Vision client, and when a storage object is finalized, meaning there's a file uploaded to cloud storage, we'll get the path of the file, determine if it's interesting to us, then build a cloud storage URL. That gs:// that's a cloud storage URL. So now we're telling, we've got this URL that uniquely identifies the file that was uploaded. Then we'll take the image annotator client, call its label detection method, get the list of labels back, and then write that into Realtime Database. That's all it's doing. It's just really not even 30 lines of code. So let's see how that works. Looks like the deploy completed. So what we can do is, one other thing I need to do. Since this is a website, I need to run. I need to Firebase init hosting. So I'm going to use Firebase hosting to host this. Okay, so what that did was it created a new area called public, and it gave me a regular old index.html. What I want to do here is copy some files in here. So hosting, I need to copy, whoops, I need to copy this recursively. Okay, so now I've got some new files in here, just some simple HTML, a very simple UI. This is about 100, not even 100 lines of JavaScript code that does the DOM manipulation. So it's handling the drag and drop, it's handling the upload to cloud storage, it's handling uploading metadata to Realtime Database, and then it listens at that location in the database for the update from the function. So what I'm going to do here is Firebase serve only hosting. And what that's going to do is it's going to take that content and start. Oh, port 5000 is not available. Oh, that's because I'm running the emulator here as well. We can't have that. Okay, so now we have a URL. I'm going to copy that into a new browser. So that's just the default page. I don't want the default page. I want my upload page. So here's my little drag area. Let's make this bigger. And I don't need this anymore. Okay, so what I want to do is show what's in database and the image drop at the same time. Come on, here we go. So what I can do here is start dragging images. So here's an image from a game I used to like to play a lot. I'm going to drop it in there. So it's going to generate a download URL and show a thumbnail of it. And hopefully we'll get some labels. Fingers crossed. Wonder if this is the part in the demo where I did something wrong. Let's see. I'm going to check the log. Oh, I know what I did. I forgot to export it. So it never actually deployed. Oh, I actually didn't. Yeah, I didn't deploy it at all. Firebase. Okay. Let's just forget that one ever happened. Actually, we don't need this one anymore. Deploy faster. So just to remind you, this is what was actually implemented just now. So it's going to, the important thing is the Cloud Functions trigger. This is what's driving everything. This is where all the most complicated stuff is going on. The client is relatively dumb. All the smart stuff is in Cloud Functions and Google APIs. So hurry up with that. Okay. Let's try this again. It might not have been fully deployed yet. Oh, no, there it is. Okay. So you can see now, let's close up scores and open images. So you can see that the labels got updated in real-time database and they got reflected in the client. So let's try another one. Here's a bunch of mobile devices. So you can see it got updated here. Okay, so we have technology, furniture, electronics, wood, flooring, electronic devices, desk, machine. Not bad. How about ice cream? Everybody loves ice cream. Aha. Not a bad assessment. Let's try one more. By snowman. Yep, so pretty neat. You can see that Cloud Functions kind of drives the interaction with the client here. The client is doing something to stimulate a Cloud Function. That Cloud Function is doing kind of the heavy lifting. It's doing kind of the secret stuff and then returning the result to the client. Now we could do this over HTTP as well, but I like using Cloud Functions database triggers as a way to write metadata into a function and then store the related data to that function in the same location of the database. That's a pattern I like, but there's a lot of different ways to implement this with Cloud Functions. Okay, one more thing that I want to talk about is one other thing that I built. This is going to require some participation with you, so get out your mobile device, get out your laptop, and put this short link in there. At least one of you has to do it, because it's not an interesting demo if one of you does not do it. So what this is a universal translator. And how it works is there's a mobile device, an app. Now this app is mine. I have the speaking app. The website is the listening app. And what happens is I'm going to say something into that app. And what's going to happen is this app is going to use, and it's an Android app by the way. It's going to use Firebase APIs to write metadata to Firestore, upload the audio to cloud storage, very similar to the last sample. Then I'm going to that cloud storage upload is going to trigger a cloud function. And that cloud function is going to read the metadata from Cloud Firestore and then use both the audio and the metadata to call the Cloud Speech API. So it's going to translate that audio into actual text. It's going to get a transcript of what I said. And then it's going to feed that into Translation API. So now I'm going to request, 8 or 9 different language translations of what I just said. So with those translations, I'm going to go write those translations back into the same document in Cloud Firestore. And then your client, the web client, is going to be listening at some location. It's going to be listening for those new results. And when those results come through, you're going to see the translation. It will also speak it out loud. So I believe there's a language selector. So if the volume is up on your phone, you can select the language you want to hear it in. So let's see. All right. I don't know if there's going to be echo. How is everyone doing today? It's that cold start time. It's killing me. Please tell me it's working. Actually, I don't think the file ever uploaded. It's that Devoxx speakers Wi-Fi. I need a new Wi-Fi, I think. Oh, you did? Oh, you got one? Okay, I don't even see it on mine yet. I should see it in my app. That's just how bad my Wi-Fi is. Let me get off that. Actually, here's what I'm going to do. I'm going to run it in an emulator. That way you can see it too. You can see what I would have seen. And by the way, you can get the source code to this. So the Android app and the Cloud Function, all of this is all open source. I'll give you a link to that afterwards. I think it's kind of fun to play around with. You see that okay. Okay, run faster. Aha. Okay. Let me try. Let me try some Japanese. So, I know a little bit of Japanese, enough to order beer. Biru ga nobitai desu ka? So uploaded. Okay. I don't know what language that was. Let's see. What do I want to do? I know some French. Let's see. Oh, I don't know any Russian. Oh, what should I say here? Bonjour, mes amis. Ah, that was okay. Well, does anyone want to try one? So Ukrainian is in here. Does anyone want? I've not had anyone actually try. Does someone want to come up here and give it a try? Come on, don't be shy. What was that? Somebody come up here. Someone. There'll be a prize. I'll give you a sticker. I'm sorry? This one? I don't know how to pronounce that. I can't read Cyrillic lettering. All I know is A through Z. Very, very limited. All right. Anyone have any ideas? Okay. Oh, yeah. Where is that? Here. Okay, so the way it works is push the button, say what you want, then push the button again. Oh, it's the whole laptop. Yeah, so I'll push the button.
Enjoy lunch.
Okay. And see how well it does. Oh, that's not.
It assumes every word in Hebrew is like from the Bible or something. Because Tehillim is a Bible book.
Ah, okay. You want to try another one just for fun?
I don't know. Okay.
All right.
תהנו משאר הכנס. Enjoy the rest of the convention.
Okay. This is terrible.
That's Hebrew,
Yeah, all right. Well, thanks for trying. That was fun. I'm gonna have some stern feedback for Google at the end of this. Anyway, let's go back to the presentation here. Oh, that's my other talk for today. That's okay. Where is it? My talk is gone. Oh, there it is. Okay. All right, so anyway, I've given you a lot of reasons to use Cloud Functions. I'm just going to be honest and say that Cloud Functions is not for everyone. As you saw, there's a cold start time. For that first time that your function executes, it's going to take a little extra time. And that little extra time could be between 100 milliseconds and 4 to 5 seconds. If you can't tolerate that, and some apps can't just because of their requirements, you should not use Cloud Functions. Instead, you have to maintain your own server. And so you could use App Engine or your own hosted service, but you will pay for the servers 24/7. It's just going to cost you more, but you eliminate the cold start times. If you have really heavyweight work to do, Cloud Functions is not good. The maximum time a Cloud Function can run is 9 minutes by configuration. If your work is going to take more than 9 minutes, forget about it. Cloud Functions is not for you. Also, if you need more than 2 gigabytes of combined disk and memory, so the disk you can write is actually a memory file system. If you need more than that, again, you should consider using something else. Now, you can use Cloud Functions to trigger your work, but you could delegate that to something like App Engine or Compute Engine. So that's a pattern that I have yet to experiment with, but I'm told it works really well. If you need to keep a socket open or do some streaming, again, Cloud Functions is not for you. You should consider something else. There's a lot of other options out there, but it's probably going to involve running your own server. Cloud Functions gives you a lot of benefits. It gives you the ability to write and deploy code without managing any server, scaling up and down. You can glue together different APIs and services really, really easily with minimal amounts of code. I think it's really fun. And if you want to learn more about Firebase, so that first link will tell you all about Firebase. It's a rather lengthy blog. If you want to read documentation, these video tutorials is more of just me talking. So I do these videos. So if you didn't enjoy watching me talk today, you're not going to enjoy these videos. We have tons of samples. There's something like 30 or 40 different samples. There's a code lab you can go through if you want to do more of a step-by-step hands-on approach. And some of the samples you saw today are in a gist that you can see there. The Universal Translator code is here. And so there's a bunch of projects here. The project is called Universal-Translator. It gives you all the steps that you need to do this demo that I showed you today. So it does require billing enabled, but it's very likely that you won't use it enough to actually incur any billing. So don't be afraid to give your credit card. As long as you get in, do your experiment, and get out, you don't have to worry about any crazy amounts of billing. That's all I have today. You had a question, right? Yeah.
Thank you. So it's very much like AWS Lambda, right?
Yes, very much.
So what are the benefits of Firebase comparing to AWS Lambda?
Well, with Lambda, you won't be able to trigger off of any of those Google or Firebase products. So if you want to write a Firestore trigger, you're not going to be able to do that with Lambda. The benefit with Cloud Functions is that you are gluing together Google products and services all into one project. We like to think of it as programmatic glue. You could use another service. You could use Lambda to write an HTTP trigger that turns around and queries Firestore or Realtime Database. If that's all you need to do, that's fine. But if you want to do the product triggers like Cloud Storage, Firestore, other Firebase products, you need to use Cloud Functions. So.
When we do deployment of a function, does it mean that all the dependencies, third-party libraries need to go with that package all the time we deploy it?
Right. So it's actually not the case, and I'll show you something to help ease your concerns about that. So you saw in the deployment how much was actually deployed. 64 kilobytes. Now that's obviously not all of Firebase admin, Firebase functions, and Lodash and everything. That is just your code. Now what happens on the server side is it's going to do an npm install of everything in your package JSON, in your package lock. So all of that stuff does not get uploaded. It's installed sort of behind the scenes. So you don't have to worry. A deploy is actually very cheap. So. Any other questions? Oh, yeah. So we have a microphone here. There's someone in the back who could use the microphone.
And what about that variables that you defined about when you authenticate to Google services, like Google Sheets and
I'm sorry, say that again, the
yeah.
question.
What about when you redeploy your function and you already authenticate to Google Sheets? What will happen with this variable?
Oh, so if you redeploy,
Yeah.
so it will eliminate all other instances of that function. The authentication just goes away. Everything is cleaned up, all the containers. So you can think of it, if you're familiar with containerized deployments, what Cloud Functions is doing for you is creating a container with a Node.js project with your function in it, ready to go. It's a blank slate that just runs your function. So the old version of the function goes away. The container is destroyed. The new one takes its place. So it has to re-authenticate every time. So that code that runs in the global scope will run in the global scope for every function, for every server instance that gets allocated for that function.
Thank you.
Yeah.
Thank you for the presentation. I have one question. So I have previously worked with serverless and about the cloud functions. So so is it cool for writing the tests, actually for testing your code? And what kind of frameworks I need to use for writing the tests, or I just don't need to write tests because my cloud function is so little, so it's obviously it's working right.
Yeah, you should always write tests.
So there is some special frameworks or Google Cloud?
Yeah, so there's two ways to test your functions. So you saw I ran Firebase serve, and it picked up my HTTP function. I can test it that way. For non-HTTP functions, when you run Firebase, there's an emulator for that. And the emulator gives you a CLI where you can construct direct calls to your function and make sure that so you can test locally. Now that's not enough. Local testing by running it is not a great test. If you want to do unit testing, there's a Firebase Functions test module that you can install, and it allows you to pick out triggers and invoke them manually and mock and stub and do all that. So if you use Mocha and Sign-On, or Sign-On, I don't know how to pronounce it. If you use those frameworks, you can use those against Cloud Functions for Firebase. So, and if you go to the documentation, there are examples of how to use that. So, right now, the module's in beta. There was a new version just released the other day. But yeah, the team takes that seriously. Testing should be a part of your deployment. So.
Hello, thank you for the talk. So can we rely to the Google Functions to register some webhooks from third-party services, which works in asynchronous way? Is it good way, good pattern to use Google Function, for example, receive some event and persist in the pops up and for future processing?
Yeah, so doing asynchronous calls like that is a pattern. It doesn't happen very often, but sometimes, like you say, a service can take an indefinite amount of time and it can't return you a result directly. But if you can publish to a pub subtopic with the results of your whatever computation is, you could write a pub sub function to receive those results on a topic and figure out how those results should be matched up with the original request. So that's something that you can do. In fact, there's a new product out there in beta right now called Cloud Tasks. And with Cloud Tasks, what you can do is tell Cloud Tasks, hey, I have some work I want to schedule later. Maybe 3 hours from now, a day from now, 2 days from now. And that task sits out there indefinitely until the time is elapsed, and you can have it ping your pub sub function to continue the work after some delay has happened. So I'm actually thinking about writing a blog post and some examples on how to do that, because it's asked very, very frequently, how do I schedule my cloud functions, both with cron and on some delay, so like an @ style. So yeah, what you're describing is something that is okay for cloud functions, I think.
Hi, could you tell, is it in plans to use Java API beside Node.js and Python?
Yeah, so Java is maybe the most requested runtime. And at a conference like this, everyone is going to want to do Java, right? The tricky thing with Java and JVMs in general is they have a terrible, terrible cold start time, right? It just takes a long time to fire up a JVM. So I don't know where the team is on that. I know it's highly requested, but I don't think there's a roadmap for Java right now. I mean, something's going to happen to make those that JVM startup time very, very slow, or very, very fast, so that cold starts won't be problematic. But yeah, it's maybe the best thing you can do right now is write Kotlin and transpile that to JavaScript and then have your JavaScript run in Cloud Functions, which I've done, and it's very painful, and I don't think it's not ready for prime time yet. But that's honestly your best solution right now. It's not great. Sorry, I don't have any better information. So. Anyone else? Any other questions? Awesome. Well, thank you all for showing up, and I'll be hanging around here later on if you want to approach me directly. So thanks again.